Hello, and welcome to your statistics lesson. In this video, this is the third of 3 videos dealing with standard normal distributions. And in this case, we're going to talk about what if you know the area and you want to find a z-score. We talked about what are probability density curves and about the area being under 1, and then looked briefly at the shape of the standard normal distribution in the first video. In the second video, we used standard normal distribution to take a z-score and calculate the probability that a particular reading was greater than or less than that z-score. And now we're going to do that in reverse. We're going to know the area, which is a probability when you're talking about a probability density function. And we're going to find the z-score from knowing the area. And this would be a way you would if you knew a critical value had occurred at a particular after a particular amount of area was covered, then you would be able to find the z-score and then back off and find the data point that would create that. That would be in the margin of that. So we are mostly going to use the TI-8384. Finding z-scores from a known area, basically they're saying you're going to draw the bell-shaped curve and draw a picture of what you're doing. That's always a good idea if you can do that when you're solving a problem. If the region's not cumulative from the left, in other words, you're not looking for an area that starts all the way to the left and goes up to the point, some point, then you're going to work with the known region that is cumulative from the left. Let's move on. We're going to use this inverse norm command, and this is in the distribution menu, the second vars menu of your TI-83 or 84 plus. So when we do this, I guess I have to click on that first. Okay, here's an example. So to find a critical value, and you went for the standard normal distribution, a critical value is a z-score on the borderline separating those z-scores that are significantly low or significantly high. A lot of times we're looking at a z-score of a -2 for that, but you to be significantly low, a z-score of a +2, be significantly above a +2 to be significantly high. But let's see what we do in this example. So the expression z sub alpha, this right here is a Greek letter alpha. Don't go crazy over that's a funny symbol. Just, okay, when you see this, you know it means the z-score with some area, alpha. So alpha is going to be a number. It's going to be a number less than 1, between 0 and 1. So if I were to say, this is not letting me write, sorry. If I were to say z 0.5, I would be asking the z-score that has an area of 0.5 to its right. Now here's your standard normal curve. I have to draw really slowly with this. And there's your mean. Well, guess what? The mean, your z-score would be 0. You'd be right at the mean for a 0.5, the area of alpha to its right. If I wanted a z-score of 0.25, that would be over, the z would be over here somewhere, probably further back here a bit, but you would see it be a z-score greater than 1. If you wanted a z-score, if this alpha is something that's less than 0.5, your z-score is going to be negative. So basically what we're doing is we say this is the area we want, let's find the z-score. That's what we're doing when you use the inverse norm function, INV norm. So let's find the value of z sub, when we say that sub z with the alpha is 0.025. So we want to find what z-score gives me an area of 0.025 to the right. So using the TI-8384 to get this inverse norm command, you're again doing second, and then you press the vars key because that brings you to the distribution menu. I have to write really slowly here. I don't know, maybe my computer is just too slow for this. And then you choose inverse norm. Now, why is this a 0.975? I thought we were dealing with a 0.025. Well, the inverse norm works with, so you wanted to know the z-score the area is, or the probability is 2.5, this would be something somewheres around where that 0.025 would be. It's probably even further to the left. But for now, so you wanted to know the area to the right of this. Well, since the standard normal curve is symmetric, it would be the same if this distance from here to here, if this probability was 0.025, this would be the z-score of 1 minus 0.025. I'm sorry, this pen is not writing well. That number up there. So what this inverse norm function does is it finds the area to the left of 0.975. Sorry, that does not say left very well, does it? And that will be the same as the area to the right of 1 minus 0.975 because of the symmetry. So if it from here to here is 0.025 and you want the area above that, you can start from, remember the total area would be 1. You're really way out here. You're not there, but 1 minus 0.25, and this also goes way out here. 1 minus 0.25, the area to the left of that will be the same as the area to the right of this. So that's what you put in there. So if you went to the area to the right, you have to do 1 minus that and put that number. And then again, this is the mean and the standard deviation. If this is a standard normalized normal curve, you get a 0 for the mean and a 1 for the standard deviation. So the area results in a z-score of 1.9599. So just about 1.96. Now, because you did this, your z-score is actually going to be a negative 1.96 for the answer to your question if you had to do this changing around the left and right. That's one of the more complicated things to do with this inverse normal function. We won't be using that a lot, but I wanted to make sure you saw this example and we went through it. I'm not drawing anymore. Let me stop drawing, and then if I do this, it should let me move. So I found this, but what I really wanted was this. If you're finding the area to the right of a curve, you do 1 minus that, and that gives you the corresponding area, but it'd be to the left. So if your z-score comes out positive, your z-score will be negative. If your z-score came out negative, your z-score will be positive. So this is really what you wanted. That is a little tricky, and I will do more examples of that if we find we're going to be using that a lot. All right, this is the last video for this section. Email me your questions. Check out the other things I have posted. I have posted instructions for using the TI-8384 with the standard normal distribution. I've posted several documents on that. I've posted some other videos and a link to some other sites that will give you instructions.